Unit 6, Part 1. Unit 6 is on further applications of the truth table method. In Unit 6, we're introduced to a whole bunch of what we're going to call truth table concepts. So concepts that have a certain truth table definition. Okay, and what I've got up on the table, this will be with us throughout the whole lecture on this unit. This table lists all the concepts you need to know. Validity and invalidity, that we already have, but we'll have that up to distinguish it from the other concepts. Concepts you're learning here in Unit 6, tautology, contradiction, and contingency, logical implication and logical equivalence, and consistency. Okay, near the end of the chapter, beginning of section 5 on page 106, section 5, 4 kinds of truth table problems and the relation between them. On that page, Klenk runs down the difference the difference between all these concepts with regard to what they apply to, and that's what inspires this table. Okay, to get clear on what all these concepts are, you have to get clear on what they apply to, and you'll be making category mistakes if you apply, say, the concept of validity or invalidity to a statement form, or if you apply tautology or contradiction to an argument form. It's a category mistake. These concepts separated by different lines here apply to different things. Okay? So I'll run through that. The third column is going to be an image, right? These are truth table concepts, and you're going to you should learn how to associate a certain truth table image with each concept. For example, you'll come to think of tautology. The image is just going to be a column of all truths, right? I'll expand upon what that is, but the certain image, you want to understand the concept of tautology, or to think it's a column. A tautology is a statement form where the column under the major operator for the truth table is all truths, all T, okay? And similarly, a contradiction is going to be same but all false, and a contingency, same but true and false, right? And there are similar truth table like or truth table defined images for all of these. For example, consistency. What is consistency? It's going to be consistency is going to apply to sets of statements, and a set of statements is consistent when there is one row, not column, but one row in the joint truth table where all the statements come out true. It is consistent. A set of statements is consistent if there exists at least one row in the joint truth table where all those statements come out true, right? That'll be a truth table explication of consistency, in the sense of a set of statements is consistent in that they can all be true at the same time. So the image you're going to associate then is going to be a row, right? Not a column, but a row. And when Klenk, let's say this will be if there's 4 statements, 4 columns of T's, might be 3 if there's 3, whatever it is. So notice the difference between the image you're to associate with tautology. Tautologies are going to apply to statement forms. It's going to be a column. For consistency, a set of statements, at least one row where they're all true. And Klenk encourages you when she teaches you about consistency. She ends by saying, don't confuse tautology and tautologies and consistency. Crucially, they'll be in different columns here. They apply to different things. Okay, and the truth table images you're to associate with them when you think of these concepts are going to be different. Okay, so let's run through them. The concepts of validity and invalidity, as we've said repeatedly, right? They apply only to arguments or argument forms. Okay, they apply to particular arguments by virtue of applying to argument forms, because again, an argument is only valid if its form is valid. Blah, blah, blah. I've heard that 100 times. Okay, so that means it's a category mistake to apply the concept of valid or invalid to a particular statement form, or even to merely a set of statements or statement forms, right? It's got to be to argument forms, so sets of statements separated into premises and conclusion, right? Consistency is going to apply to sets of statement forms. It will be also a mistake to apply validity to a mere set of statement forms, right? Similarly, it would be a mistake to apply the concept of consistency to argument forms, right? Got to apply the concepts to the right things. All these concepts apply to specific things, and you have them wrong if you get the wrong thing. Okay, validity, invalidity apply to argument forms. We're familiar with that. These concepts, the first ones introduced in Unit 6, tautology, contradiction, and contingency, all apply to the same kind of thing. These all apply to statement forms, individual statement forms, okay? Now, what I recommend is, right, you have already some kind of intuitive understanding of what a tautology is, certainly of what a contradiction is, also of what a contingency is. You can rely on those to remember what each of these concepts are specifically in terms of their truth table definitions, but what we are giving for them now is specifically truth table definitions for these concepts. Okay, they all apply to individual statement forms, right? So you will test an individual statement form, right, for whether it is a tautology, a contradiction, or a contingency. Every single statement form has to be one or the other. Tautology, as you would expect, so the classic tautology, or the paradigmatic tautology, is a statement form like P or not P, to be or not to be, right? That has the form P or not P. So tautology, as I said before, tautology you associate where tautology is a statement form where the column under the major operator comes out all true, right? Column under the major operator, because as you'll see if you do the exercises, right, where they ask you to test statement forms to see what they are, which one of these things they are, tautology, contradiction, contingency. They're often very complex statement forms, so you have to calculate the sub-formulas, right? How many variables does it have? P, Q, okay, so 4 base columns. This one's got P, Q, R, so 8 base columns, right? Oh, there's lots of sub-formulas, it's very complex. I have to calculate the sub-formulas. I have to compute the truth value of the sub-formulas first before I can compute the truth value of the actual statement form itself, right? That's why in the definition we have the truth table, the column under the tautology, the column under the major operator is all true. And as I've stressed, right, the major operator is what the statement is. Right? If the major operator is the hook, then that statement is a conditional. That's what it is. Right? What form has this statement? What is this statement? It's the same as asking what is the major operator of this this formula. Okay, so I mean, if you what would the truth table for P or not P be? Of course, it would be, right? Okay, how many sentential variables? Just one. So how many rows in my truth table? 2. All right. So P or not P. I'm working out the truth table. P or not P. Okay, so not P is going to be false, true. So true or false is true. False or true is true. Sorry, that should be under here. True or false is true. False or true is true. Right. The column under the major operator is all trues. That's a tautology, as you'd expect of P or not P. Right. A tautology is a statement that can't possibly be false. Right. You haven't said anything meaningful because P is true or false. If I say P or not P, you say, oh, well, thank you so much for your very informative statement. Right? There is no possible world in which that doesn't come out true. So you've just spoken tautologiously, in a sense, meaninglessly. Right? You haven't committed yourself to anything contingent. Okay, that's a start. We'll continue in part 2.